In this session, let's look at a sample application of array. This sample is an example. This example is a recursive question solution. So we already went through recursive question before. A recursive definition is used to define an element in the series in terms of other elements, usually previous ones in the series. So the factorial, let's say use a Fibonacci series as an example. When n equals to 1 or 2, Fibonacci n is 1. When n greater than 2, then the nth element of Fibonacci series is the sum of the n-1th element and n-2th element of Fibonacci series. We use recursive method to resolve recursive issues, which is a method that can cause itself, usually with a previous element or an index to the previous element, thus forming a recursive series. Recursive definition can make certain definitions simple, thus it's very useful, for example, in handling time series. So we previously implemented a Fibonacci solution with a classic recursive definition. A Fibonacci series, we do this way, and I mentioned a lot of times we use the word fib to be the short form for Fibonacci series. So this is how we calculate. Fibonacci n equals to the sum of Fibonacci n-1 and the fib n-2. Then n-1 equals to the sum of n-2 and n-3. This is a classic mathematical definition of Fibonacci series. However, this solution comes with a performance hit. The same element is calculated multiple times. For example, when we start calculating n, we first by calculating -1. And in -1, we need to calculate n-2 first, and so on and so forth. When we finish calculating n-1, we will go back to the calculation of -n of a fib n, which equals to n-1 plus fib n-1 plus fib n-2. Then we need to go through this for n-2 again. But in fact, we already calculated fib n-2. So the whole branch is a repetitive work that we're repeating everything. Similarly, the n-3 here is also, the calculation of fib n-3 is also a completely redundant work, which has been done before. So this, when n is large, can really drag down the performance. You are basically doing the same thing again and again for no use. What we can do is, since this is already calculated, fib n-2, we can save it somewhere, which I already put, save the nodes previously calculated into an array. When we need to calculate n-2 again, we will go to the array, use the value, instead of recalculating the whole branch. So this is how we do it. Let me clear this first. And let me see, this is the original Fibonacci series we calculated, and I add system print executed once here. So when I run this, it actually runs, I don't even know how many times it's calculated. Let me copy this. Let me copy the whole series up and paste it here. Let's see how many rows it is. It's 109 times of execution. And let me start a notepad and write the classic calculation is 109 times for fib 10. Now, let's do the quicker way by creating a integer, let's call it integer array called fib series. When we create this fib series, we will assign it an initial size, which will be int n, and the fib series equals to new int n. So this is the Fibonacci series. Now there is an issue though. In calculation, in mathematical calculation, we start at 1 and end at n. But mathematical definition. But in the Java definition, we start at 0 and ends at n minus 1. I should copy this here to make it clear. You have two ways to resolve it, two ways to make your life easier, for better mapping. The first way is always keep in mind there should be a +1 for mathematical definition, or maybe I should say -1 for n. Keep the conversion throughout your code. The other way, which is what I'm going to use, is create a Java array of 0 to n. So what I'm going to do is actually integer n plus 1. I'm not going to use the 0 element, will not be used. Rather, I will just use the 1 to n elements of this array, just to make life simple. And also, we already know that the first element should be 1, and the second element should be 1, 2. So once you create this array, everything in it is 0, unless you populate it. Now let's create the public int method for calculation, for the actual calculation. How do we calculate? Remember we said if the nth value has not been calculated, then we will calculate it. Fib n minus 1 plus fib n minus 2. And how do you determine this has not been calculated? Because because all Fibonacci series will be positive integer, non-zero positive integer. So, and the Fibonacci series array will be initialized to 0. So if it's equals to 0, that means it's not been calculated. Then we will return this Fibonacci series. Right, so if we already get the definition here actually. And we will calculate this as fib n minus 1 and fib n minus 2. All right, so now let's create, I'm going to copy a main method, which will create a new fib10 and calculate fib10. As we said here, every time we call fib, I'm going to print out the execute once and see how many times this is actually executed. Now let's run. And this time apparently is much less. Let me still copy this just to see how many rows. 17. So it's 17 rows, 17 calculations, whereas calculation use array 17 times for fib10. So you can see how many times. What's the difference between this? And this can be a huge performance hit. So array can be used for in a lot of environment to save certain processing. And this is one of the most powerful thing in Java language and actually in all computer language. Because if you think what's the power of computer, is that it can do the same thing again and again without mistake, really fast. An array is a perfect choice, perfect choice of data structure that you can use. You are just defining an array of one data element, or of one data type or object type. Then you will perform the same operation in a large scale in a very fast manner. And that's the power of computer. And that's why array is so important.